Exponential decay is the lesson that we're on right now. And in exponential decay, what we're going to do, that's 1.7 point D, what we're going to do is see how much things change in a bad direction. A flywheel is rotating at a speed of 50,000 RPMs. When the power is disconnected, the speed decreases exponentially. So decay means a decrease. And if you notice, it's 5% per minute, and they have -5 because it's decreasing. Next, it says, notice we've got the coefficient of E is the same as the initial amount. So let's plug it into our calculator, and we'll take 50,000 E, so that's shift ln E to the negative 0.05 times 3 minutes, and we get 43,035.398. And if you notice, they want us to round it to the nearest hundred, which would be 43,000. Next one. A certain radioactive material loses its radioactivity. It decays at a rate of 20% per year. After how many grams will remain after 4 years? I don't know what that decimal point is doing in there. Use the formula 640. Note our coefficient is the same, and it says 20% per year, so that's where the 0.2, and it decays, so that's negative. And on our calculator, we're going to just press 640 shift ln E to the negative 0.2 times, and it says, I forgot how many years, 4 years. And we get 288 grams. Next one. A certain long pendulum released from a height of 24 centimeters. So I'll show you what that means. So it's going to be released at 24 centimeters. So this distance is 24 centimeters. What height will it be at in 3 seconds? So it loses its height at negative 0.45 times the height. So on our calculator, round your answer to the nearest centimeter. On our calculator, let's see here, we've got 24 E to the negative 0.45 times 3, and we get 6.2 centimeters, which is closest to 6 centimeters. All right. And next one. This is probably a very important kind of problem that you would run into if you were either in insulation or in heating and HVAC. At an initial temperature of 40 above the outside temperature, a room cools exponentially at 15% per hour. In other words, it's colder outside, and the room cools if heat isn't added at 15% per hour. Find the temperature the room is above the outside temperature after 6 hours. So if you notice, once again, our initial is the coefficient of E, and it cools at 15% per hour. So we're going to take, I forgot how many hours, 6 hours. So it's going to be 40 shift ln E to the negative 0.15 times 6, and if you notice, after 6 hours, it's down to 16 degrees above the outside temperature. Last one. After a toy it passed its peak in popularity, like Tickle Me Elmo, sales continued to decline at 5% per year. Find the sales after 3 years. If the peak was 76,000, use the formula 76,000 e to the negative 0.05 t. Notice the coefficient of e and the rate are both given. After 3 years, we want it to be, 3 years. So it'd be 76,000 e to the, and it declines 5%, so negative 0.05 times 3, and we get 6, we want it rounded to the nearest hundred, 65,400. If you have any questions, give me a buzz. Otherwise, good luck on your assignment.